hi, good afternoon, greetings, salutations. My name is William and I'm going to be presenting my project for AC circuits. It is currently Friday, October 21st, about 6:30 p.m. This is an ultrasonic sensor that I will be demonstrating for you here in just a moment. This electronics kit that I've breadboarded is an ultrasonic sensor. It is capable of detecting an object up to 1.5 meters away, as long as it passes in front of the sensor. This quartz crystal generates a 10 megahertz signal that is fed into this binary counter, dividing the frequency by 2 to the 7th, which brings it down to approximately 78 kilohertz. The 78 kilohertz clock signal is fed into another binary counter, which divides the frequency into a set of 8 harmonic frequencies, the smallest of which being approximately 38 hertz. These frequencies are fed into this 8-input NAND/AND gate. This outputs 2 signals, one from pin 1 and its inverse from pin 13, which are used to dictate whether or not the buzzer has power. But before I delve any further into this portion of the circuit, I want to change gears and focus on the sensors. There are 2 sensors. Sensor 1, which emits the ultrasonic frequency, and sensor 2, which detects that frequency. For sensor 1, in order for it to emit the ultrasonic frequency, 2 signals are fed into one of the NAND gates. This will be the clock frequency from IC1, which is 78 kilohertz, and the signal from pin 1 of IC3. The value of that operation is distributed through a series of buffers in IC5 that allow for the sensor to emit the ultrasonic frequency. For sensor 2, when it detects an ultrasonic frequency emitted from sensor 1, that signal is passed into IC6 through a series of op-amps that compare that received signal to the one supplied by pin 1 of IC3. Until the value of the received signal surpasses the value of pin 1, the not read-write signal will remain high. However, once the value is surpassed, the not read-write signal will go low. Now let's cycle back to this portion of the circuit. The signal from pin 1 is fed through this potentiometer and resistor. By adjusting the resistance of the potentiometer, the detection range can be modified to be either closer or further. This output is fed into IC4, which is a quad 2-input NAND Schmitt trigger, along with the output from pin 13. The value of this operation is stored in a flip-flop by using 2 of the NAND gates in IC4. This value, which is a logical 1 until the distance threshold is passed, is inverted at pin 9 of IC5 into a logical 0, which causes the buzzer to remain off. However, if sensor 2 has detected something within the distance threshold, the not read-write signal will output a logical 0, which is fed into the same flip-flop from before, but now this value is inverted into a logical 1, causing the buzzer to toggle on.